Combination reaction.
The combination of a substance with another to form a new substance, or the decomposition of a substance into two or more different substances, is called a chemical reaction. In general, chemical reactions are not reversible except by further chemical reactions and may require heat to enable the reaction to occur. Those reactions that produce thermal energy are called exothermic reactions. Chemical reactions can be classified into combination, decomposition, displacement, and double displacement reactions on the basis of the type of changes that take place in the reaction. Combination reactions are those where two or more substances combine to form a single new substance. Decomposition reactions are those in which a single compound breaks down to produce two or more simpler substances. The reaction in which a more reactive element displaces or removes another element to form a compound is called a displacement reaction. Reactions that involve displacement of two different atoms or groups of atoms by other atoms or groups of atoms are called double displacement reactions. The experiment aims to study the action of water on quicklime and classify it as a combination reaction, decomposition reaction, displacement reaction, or double displacement reaction. Materials required: quicklime or calcium oxide, distilled water, beaker, and a spatula. Procedure: transfer a small quantity of quicklime or calcium oxide to a beaker using a spatula. Slowly add distilled water into this beaker. Pour enough water so that quicklime remains submerged in water. Here, quicklime reacts with water and forms a suspension of slaked lime in water. This is a combination reaction as the two reactants, quicklime and water, react to form a single product, calcium hydroxide, that is, slaked lime. This reaction is exothermic in nature as it releases thermal energy in the process. Now, keep the beaker undisturbed for some time. We can see that the clear solution appears as the suspension of slaked lime settles down. This clear solution is known as lime water. To confirm the presence of calcium hydroxide in lime water, add a few drops of clear solution, that is, lime water, into a boiling tube. Close the mouth of the boiling tube with a cork and insert a glass tube into it. Then blow exhaled air into the lime water through this glass tube. On blowing, carbon dioxide contained in the exhaled air turns lime water milky, which proves that lime water contains calcium hydroxide. Precautions: always pour water into a small quantity of quicklime taken in a beaker. Never put quicklime directly into the water as it may cause the water to splash out. Avoid inhalation of quicklime as it may cause coughing or sneezing.
Combination reaction. We'll require quicklime, distilled water, beakers, spatula, glass rod, test tube, dropper, and lime water. Take a small quantity of lime water using a spatula and transfer it into a beaker.
thermometer,
glass rod. Slowly add water into the beaker so that quicklime remains submerged in the water. Quicklime reacts vigorously with water to produce a suspension of slaked lime, releasing a large amount of heat. Leave the beaker undisturbed for some time. A clear solution of lime water appears as the suspension of slaked lime settles down. Take a small quantity of lime water using a dropper and transfer it into a test tube. Then cork the test tube with a cork and insert a glass tube through the hole in the cork into the test tube. Blow exhaled air into the test tube through the glass tube. On blowing exhaled air, which contains sufficient CO2 gas, it turns the lime water milky. In this reaction, quicklime and water combine to form a single product, slaked lime, calcium hydroxide, so it is a combination reaction.